All right, welcome. Let's see analysis of the friction on an inclined plane. Let's see and know the relevant formulas that we can use to do calculation with respect to inclined plane. When we say inclined plane is when a mass or a body is placed on a plane that is inclined at a certain angle to the horizontal. That's what we mean by that. So let's see the relevant equations or formula that we're going to use to do stops here. So this is a block of mass resting on this plane that is inclined at an angle theta. Now, if there's a force that is acting, trying to push the mass towards the upward direction, and there is another one that is counteracting it, trying to push it downward direction. Now, if this mass is stable, is in equilibrium, that means F is equals to what? W sine theta. But however, for this body to remain here, what it means is the summation of all the forces acting on it equals to zero. That's principle of equilibrium. The algebraic sum of forces acting on a body when it is equals to zero. That means that body is in equilibrium. So let's look at the different forces that are acting on this body that is at an inclined plane. First is the one that will try to pull it, over to the top of the plane, and then there is the one that's trying to pull it down, in which I believe that one is the friction. So now we have the normal reaction. You see, this normal reaction R is usually perpendicular to the plane. Like look at this plane that is in incline. You see this normal reaction is at 90 degrees to it. So normal reaction are usually at 90 degrees to the plane. So now, but when you talk about weight of this mass or this body, the weight you normally act downward, vertically downward. Weight usually act what? Vertically downward. Take for instance, even if you keep something on a kind of slopey like this, the weight will not act this way. The weight will act vertically downward. It will not act this way. The weight will act what? Vertically downward. So that's what I mean. So here we have W here, which is the weight of this mass acting vertically downward. Then for this normal reaction will act perpendicular to the plane. So if we were to draw normal reaction for this one, it would have been this way because it would be perpendicular to the plane. So now if we sketch a line to extend that of the normal reaction to this point, and you know that normal reaction relates with the weight of a body. So now we have to find out the weight component of the normal reaction. So now how do we get W cos theta? And how did we end up labeling this place theta? Because theta here means it's the same angle with this one here. So now let me analyze. You see this other inclined plane here. If I label that A to B, you see this other inclined plane here, and then we decide to draw a parallel line to it. And this is the parallel line to it. You see this parallel line to it. Now, according to some theorems of geometry, Euclidean geometry, you see that this theta here is an alternate angle here. It has an alternate angle here, which is also theta. It has an alternate angle there, which is also theta. And then here is 90 degrees. So if you do your geometry well, you find out that this other place here will be the same as the angle here, which it's okay. If you still want to do it, if you call this other place A, if you call that other place A, you know this other place, the summation of angle here will now be what? That angle A is equals to 1 is equals to 90, not 80, 90 minus theta. So if you want to get this other angle that is theta, assuming you call it z, z will be equals to summation of angle of a triangle is 180 minus this angle here, which is 90, minus this angle A here, which is 90 minus theta. So you have this will be 90 minus 90 plus theta. So that you have 90 minus 90 is 0. So that z equals to theta. That means this angle here at the top here is the same as the angle here. I'm just trying to prove that. Nobody will ask you to do that in exam. I'm just trying to show you why we named that place theta. Okay. So we proceed. So now that we've established that this angle here is the same as this angle, why did we call this place W cos theta? Okay, if you call this other line here X, and then call this one that is parallel to the inclined plane Y, and then you see that this weight is acting vertically downward, you have to resolve this weight into the components that it is its component that it is in parallel with the reaction force. That is in parallel with the reaction force. So if you do that resolution, you have that this W side is represented by X. So you have to look for something that relates X with W. So this W is the hypotenuse. That's this vertical cover is the hypotenuse. So adjacent to hypotenuse. So if you do cos theta, cos of this theta here, adjacent is X, hypotenuse is W. So that X will now be what? W cos theta. So this X now, which represents the component of the weight that is parallel to the reaction force. You see, what we have for it is W cos theta. That's how we got this W cos theta. Then for this one that is W sin theta, how did we get it? Now you see this other parallel line that I drew here that I labeled Y. So you also find a trig ratio that will relate theta with W and Y, which is sine. And sine theta will be what? Opposite of hypotenuse. Opposite in this case is Y. Hypotenuse is W. So that our Y will be equal to what? W sine theta. So this part of the weight component that is trying to drag this body downward the plane is W sine theta. And this the reaction R. The reaction, now you see that we've gotten the value, the formula for the reaction by this extended line. So the reaction now will be what? W cos theta. And then if there is a force trying to keep this one up, trying to take it off the plane, then there is another force that is trying to take it down the plane, and the force that acts in opposite direction to motion is called frictional force. So in that case, I can say that F, and since it's in equilibrium, I can say that F equals to what? W sine theta. It says W sine theta. So in that case, if you are to, but you recall that F itself is given as what? Coefficient of friction times normal reaction. So that coefficient of friction will be written as what? frictional limiting frictional force divided by normal reaction. But for an inclined plane here, our limiting frictional force is what? W sine theta divided by R, and our R is W cos theta. And then W will cancel W. Sine divided by cos is tan theta. So therefore, our our coefficient of friction for an inclined plane is given by the tangent of the angle of the inclination. So this is the most important formula with respect to inclined plane. So if we are to find the coefficient of friction of a body that is inclined, that is in an inclined plane, simply all you have to do is to find the tangent of that angle. So this is the first formula. You take note of that you really need. The second formula is that your reaction equals to what? W. Second formula is that your reaction equals to W cos theta. That's 2. And the third one is that your frictional force, limiting frictional force, is W sine theta. Okay, maybe this one, that of sine should be your first, and this one second, and this one third. So those are the three main formulas that you need to be aware of. So when a body is at an inclined plane, for you to analyze the friction, the coefficient of friction is given by what? Tangent of the angle, that's sine theta. While the reaction force is given by what? W cos theta. While the frictional force is given by W sine theta. So you watch other videos how we do example on this and see how simple it is. So subscribe to the channel in order to move the ministry forward. Then for online classes real time, you can join my WhatsApp group through the link in the description. Thank you.